Okay, here it is. This is my pot level indicator with LEDs and two registers. So yeah, at the moment it's on 4 LEDs because what I've done is I've split 1024 analog values into 4 groups. And so for each group of values, for example, for 0 to 256, the first set will turn on, in this case 4 LEDs. And then it'll increase as I turn the knob. Like that. And then back down. Should turn off, those red ones should turn off, but there's a margin in the code that can adjust that. So what I'll do is I'll type into the serial port and type in the current value. The current value is 17, so ideally if the value equals 17, it should actually all be off. So I'll type that in, M17, updates the registers, and now they're all off. And then it just works as normal. Also, a really cool part about this is that I can change how many divisions or how many sets of LEDs turn on per set of analog values. So, for example, that was 4 sets or 4 pins per division. If I type in D8 into the serial port, what we'll do is make 8 divisions, and that means for every 8th of the maximum analog value, so 1024, for every 8th of those, it'll turn on 2 LEDs, or 16 divided by 2, divided by 8. So I'll press enter, it'll update the registers, well, not registers, but everything else, and then, if I turn the knob, you can see that's the case. Only every 2 LEDs. And then back down again. And then we can also do D16, so that means 1 LED for each 16th max values. And there you go. Pretty fun actually. In fact, we can do D3. Now, 1024 doesn't divide into 3 very well. So you don't get the last LED on, and the minimum value changes up to 20. So they won't all turn off. Now, I'm not sure if this is the Arduino's power source or if it's the register's limit, but depending on which setting you're on, like number of divisions like D16 or D8, that will change the minimum value of the pot at its physical 0. So, I don't know what causes that, but that's why I added the pot margin in the code. Looking at the code, may as well scroll through it. I've done some register stuff before, so it was pretty much copy and pasting some stuff. Had some problems with order, but that was just to do with most significant and least significant bit first. Coolest part about making this work was that to get the binary equivalent of what I wanted to, I had to do 2 to the power of whatever was required, and then take away 1, and that would give me the number of LEDs in binary, but with ones, if that kind of makes sense. So the ones in a COM port here, those 5 ones means 5 LEDs are on, and so yeah, how I did that was 2 to the power of pins per division, and that multiple. I actually had to make my own power function because the other one, I can't remember exactly what the problem was with it. I I'll probably like put a caption in the video or something explaining it. Yep, so maybe a power function, serial input. Man, I love doing serial input from the user and then making all these codes. It's just really fun. And so yeah, debugging serial prints. Yeah, and really cool part is I've made it so that the Arduino will only talk to the registers if there's new data to be sent. The reason why I did this is because I think it prolongs the life of the registers because they, the clock cycles and all those input devices inside the chip aren't being used, so it means they aren't getting worn down as fast. At least that's the theory anyway. If it does or not, I don't know. If how long it does, I don't know. But it's something cool to do. So yeah, that's my level indicator with the potentiometer and 74HC9595 shift registers. Cheers.